Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It's a video on word problems, in particular word problems where no equation is given to you. Instead, you have to create the equation based on the information of the question. So from a worksheet that I've handed out, this is question 9. Ooh, a long one. Let's see what it says. Colette is going to build a rectangular garden for 3 types of vegetables: beans, tomatoes, and carrots. Each vegetable is to be planted in an identical shaped field, and each field will be separated from the others by a fence. The entire perimeter of the garden is to be surrounded by the same type of fence. If Colette has 140 meters of fencing available, what is the largest area that her garden can be? State the dimension of this garden. Okay, so let's again make sure we understand clearly what's happening in the problem, and then we'll start formally solving it. But we have a rectangular garden, and it's going to be surrounded by a fence. And inside of the garden, there's going to be 3 different areas, one each for beans, tomatoes, and carrots, and each of those is going to be in an identical field. So we can imagine something like this. So we might have beans, tomatoes, and carrots. So what do we know? So again, let's reread and make sure I'm not missing something. He's going to build a rectangular garden. Each vegetable is to be planted in an identically shaped field, and each field is separated by the others by a fence. The entire perimeter is surrounded by the same type of fence. So each of these black lines is going to be made of a fence. And Colette has 140 meters of fencing available. So I can't really say the perimeter is 140 because it's not just the perimeter, it's also these 2 additional lines in the middle that need to add to 140 meters. Colette has 140 meters. What is the largest area? So we want the largest area, which means we're hopefully going to be maximizing some sort of equation. So we want to create an equation and then hopefully be able to find the maximum, meaning find the vertex. So let's formally talk about how we're going to do this. Well, almost. Um, what are going to be, what are going to be? What will be our variables? So what are the things that we don't know? Well, look at the very last statement. State the dimensions. That's always a hint, right? If you're finding the area of something, we know that the area of a rectangle is length times width. And in this case, I don't know length and I don't know width. That's probably going to represent my variables. So for example, if we say that this is the width and this is the length, well, we can now see how that fencing scenario is going to add into it, because I need to have a fence as long as L over here and another fence as long as L right here. So I know I have to have 2L worth of fencing, but then there's also W. I need one, oops, let's take it another color. 1, 2, 3, 4 pieces of fencing that are this long. So the total amount of fencing I need is twice the length and 4 times the width. And that's how I'm going to create an equation. So let's go ahead and start formally answering the question. So again, I'll draw myself a nice picture. Let's call this L, and we'll call this W. And we're going to let L be the width of the garden. And we're going to let W be the width. That doesn't make much sense, Miss Townsend. You're right. I agree. Why don't we let L be the length? What an excellent idea. Let L be the length of the garden, and we're going to let W be the width of the garden. And of course, we are measuring in meters. So we know that area is going to be length times width, and we're going to try to maximize this particular equation, but we certainly can't maximize if we have 3 variables. So we need to get rid of either length or width. So let's create our equation that shows the relationship between length of width. And we've already talked about what it is. We know it has to do with the amount of fencing. We need 2 pieces of fencing that are this long, and we need 4 pieces of fencing that are this long. So again, 2 lengths and 4 widths. And all of that together is the 140 meters of fencing that Colette has. Now, in order for us to use this equation, we have to rearrange it so that it says either length equals or width equals. So let's go ahead and rearrange it so it tells me about length. So I'm going to subtract 4w from both sides and divide both sides by 2. Now I have what's called an explicit equation, meaning that I can clearly define L based on what's happening with W. And this is what's going to allow me to do a substitution, because area is length times W, and now I can tell you exactly what length is equal to using only the variable W. So again, I'm going to rewrite my area equation, but instead of length, I now have a value for length involving width. So there's my equation, and this is what we can maximize. So again, here's my brain, usually in green. My brain says find vertex. So how are we going to find the vertex? Well, we have a couple options here. Certainly one option is to multiply these things together, collect like terms, write it as a standard form quadratic equation, and then use the quadratic formula. Or, doesn't this look like a factored equation? It is. So if we let a equal 0, we can find the roots. And by finding the roots, we can use the symmetry property of parabolas to find where the vertex is. So let's let a equal 0, and then we'll find the roots and use them. So again, if a is 0, this bracket here could be 0, and I would have a true statement. Or this bracket here could be 0, and I would have a true statement. So what values of w does that mean? Well, if the first bracket is 0, it means that 70 minus 2w is 0. So 70 would equal 2w, so w is 35. So there's one root, and here comes the other root. This bracket is 0 if w equals 0. No math to be done. So those are the roots. So we can use the roots to find the axis of symmetry, because the axis of symmetry, by definition, will be exactly halfway between the roots. So it will be at w equals 35 plus 0 divided by 2. So the axis of symmetry is at the point where w is 17.5. And that means that my vertex is at 17.5, comma, something. So how am I going to find what that something is? And I need to find it because that something represents my maximum area. So what we do is we take, again, our equation, so this equation here, and now that we've solved for w, we sub it into the equation. So area, which was 70 minus 2w, times w, and now I substitute the value of w that's on the axis of symmetry, which is 17.5. So now let's do this math. So I'm going to have 35 times 17.5, and that gives me a maximum area of 602.5 meters squared. So have I answered the question? It says, what is the largest area? I found that, and state the dimensions. So stating the dimensions would mean explaining what the length and the width were. So I can say, therefore, the maximum area is, oh, I'm not spelling very well today. The maximum area is 602.5 meters squared. This occurs when the width is, and we know what the width is because that would be this part of the equation, right? Remember, we substituted that for w, so that would be the w, or the width. So the width is 17.5 meters, and the length is, well, we don't know yet. We haven't actually done that. So let's see, how are we going to figure out what the length is? And I'm just going to put a blank there. Well, there's two ways of figuring this out. One is remembering that area is length times width. So if you know that the area is 612.5 and you know that the length is 17.5, you can simply do division to find what the length is. The other way of finding length is to remember the equation we found up here, which clearly tells us the relationship between length and width. If we know the widths, sub it into this equation and calculate length. In both cases, you're going to get 35 meters. Okay, so that's a nice thing to remember, that when you're doing a word problem, always make sure you go back when you think you're done, reread, and make sure you've answered the entire question asked. Okay, so that was question number 9, and we'll see you maybe in another video.